Good morning, geometry mathletes. We are going to learn section 9.3, trigonometry. This is something that's super important through geometry, algebra 2, and I use it so much in pre-calculus or the trig class. It all has to do with a right triangle. So we have a right triangle right here. You know, a right triangle has one 90-degree angle in it, so I'll go ahead and mark it as 90 degrees. In this right triangle, one of the sides is called the hypotenuse. It's the longest side. The hypotenuse is opposite of the right angle. So when I look at my picture here, right angle doesn't touch the hypotenuse. These two sides, not the hypotenuse. Hypotenuse is opposite. Opposite of the right angle. Then we talk about opposite and adjacent. But in order to talk about opposite and adjacent, we have to know which angle we're talking about. So I'm going to skip ahead to this fourth line that says theta. So this symbol right here is a Greek letter, and we call it theta. It's one of the acute angles of the right triangle. Theta is also called the reference angle. Use this angle as a reference to determine which leg is opposite and which leg is adjacent. So up in this picture, one of these angles is theta. So I'm just going to choose one. I'm going to choose this one right here to be theta. If this angle is theta, then opposite is going to be the side opposite of theta. Or actually, it's probably supposed to be leg. So opposite theta, if we look across from it, this side over here, this leg over here is the opposite. I'm just going to put OPP for opposite. The adjacent side is the leg next to theta or the side next to theta. It's either the leg or the side, both mean the same. Note that the adjacent side is not the hypotenuse. So we've got theta right here, and theta has two sides. One of them is the hypotenuse, the other one is the adjacent, A-D-J-cent. Trigonometric equations are used for right triangles. All right, so let's look at these right triangles right here. It says use the reference angle to label the hypotenuse, opposite, and adjacent. So I'm going to pause the video. You can pause the video. Label for question A, the hypotenuse, opposite, and adjacent. Okay, so question A, the hypotenuse is opposite the 90 degrees, so I'll put an H for hypotenuse. Opposite of theta, I got to find theta first. Opposite does not touch theta, so opposite is here, and adjacent does touch theta, but it's not the hypotenuse, adjacent. Same thing over here. This time theta is up in the top in angle B. Hypotenuse is the longest side, which is opposite the 90 degrees. Theta, opposite of theta is O. And then adjacent to theta is A. So now we've labeled the sides. Next thing we're going to do is we're going to learn about trigonometric functions, trig functions. There are three of them: sine, cosine, and tangent. Now, you know, in math we like to abbreviate things because sometimes 4 letters is just way too long. That's way too long for us to write, and it slows us down. So we have abbreviations for each of these. So the abbreviation for sine is sine. It is not sin. There's no sinning in math, just sine. The abbreviation for cosine, way too many letters, so we abbreviate as COS, but we still say cosine. And the abbreviation for tangent is TAN. Now, I want to make a big deal about this because not knowing this is very detrimental to students when they get to pre-calculus. Actually, I mean, even in this class, you never have sine by itself. You never have sine by itself. You never have cosine by itself. And you never have tangent by itself. You always have sine of an angle. We always have sine of theta. We always have cosine of theta. And we always have tangent of theta. So this right here is of an angle. We always have sine of an angle or sine theta. Now to get sine theta, we have a formula. So I'm going to put an equal sign for each of these because this is a formula. To get the sine of theta, you take the length of the opposite leg and you divide that by the length of the hypotenuse. For cosine theta, you take the length of the adjacent leg divided by the length of the hypotenuse. For tangent theta, you take the length, of the opposite leg, and you divide it by the length of the adjacent leg. So what trigonometric functions are is they are just ratios to compare side lengths in a triangle. Ratios that compare side lengths in a right triangle. That's all trigonometric functions are. We can use them for a lot of things, but that's really all they are, is we're dividing two numbers that happen to be lengths in the triangle. And we use them so much in math, they're so important that they got their own names. So the next question is, how do we remember all of these? How do we remember them? There is a cute little saying to help you remember all of these. The saying is, SOHCAHTOA. 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 So where did we get SOHCAHTOA from? SOHCAHTOA comes from sine, S, opposite over hypotenuse. There's SO. Cosine, C, adjacent over hypotenuse. Ka. TOA is tangent, is opposite over adjacent. SOHCAHTOA. That's how we remember all three of these trigonometric functions in their formulas. All right. At the top is opposite of our hypotenuse. I don't like the way this is written. Sine of theta, let's stick that theta in there. Cosine of theta and tangent of theta. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, ka, toa. So, ka, toa. It sounds weird that I'm saying it over and over again. I hope you, yourself, say it out loud so that you can remember it. Just listening to me say it is not good enough. You need to actually say it yourself. So, ka, toa. All right. We are going to find the values of these three trig functions of the given triangles. So let's look at triangle A. I would suggest the very first thing we do is find the hypotenuse. So we look for that 90 degrees and we look opposite that 90 degrees. 6 is the hypotenuse. Then we look for theta. And theta is in this bottom corner. So opposite of theta is 4. Adjacent to theta is the one that touches it. That's not the hypotenuse. We'll call that A. Now I know the value of H. I know the value of O, but I don't know the value of A. So what we have to do to find the value of A is we have to use the Pythagorean theorem. Do A squared, nope, it's not working. A squared plus B squared equals C squared, where C is the hypotenuse. Right? So let's see. Hypotenuse is 6. So I'm going to have 6 squared over on this side. Remember, A and B don't matter, so I'll just make A 4, and B is the side I don't know. I'm going to simplify this. We're going to get 4 squared, 16, plus B squared equals 36. Now we have to figure out what B squared is. So to figure out what B squared is, I need to take away 16 from both sides. Get B squared equals 20. To get B by itself, we have to square root. And if I square root, remember, we have to plus minus. If we square root, we have to plus minus. But remember, since we're talking about an actual triangle, I can reject that negative, and I don't need that negative anymore. I just get square root of 20. Adding on, can't leave it as square root 20. That's not simplified. So we're going to break that square root 20 down to square root 4 and square root 5. We know the square root of 4 is 2. Square root of 5, we don't know. So B value is 2 square root 5. All right, now we have a completed triangle. So we are now going to find the sine, the cosine, and the tangent. So let's use SOH. S-O-H. It is the opposite side over the hypotenuse. And I've already labeled it, so this should be easy. Opposite is 4. Hypotenuse is 6. Do we ever leave this unreduced? Never. So we will reduce by 2. Divide the top and bottom by 2. And we get 2/3. The ratio of the opposite side to the hypotenuse is 2 to 3. Cosine is ka, C-A-H. So we do the adjacent. Adjacent is 2 square root 5 over the hypotenuse, 6. To reduce this one, if they are in the same location, if 2 and 6 are both not under the radical, I can reduce them. I'm going to reduce by a value of 2. So I get just a square root 5 on top over 3. So there's my cosine. And then my tangent is TOA is 4 over adjacent, which is 2 square root 5. Reduce the 4 and the square and the 2 because they're both not under the square root. I get 2 over square root 5. And then at this point, you say, hold on, we are not allowed to leave a square root in the denominator. It is not simplified if I leave a square root in the denominator. So we have to multiply by a value of 1. We have to multiply a number on top and bottom. That does not change the value, but changes the appearance. Remember in class, we were multiplying by square root of 5 over square root of 5. I'm going to multiply straight across, and on top, 2 square root 5. On the bottom, I have square root of 5 times square root 5. So I get square root 5 squared. On top, 2 square root 5. On the bottom, if I square root and then I square, they undo each other. They're inverses. So I get just 5. Can I cancel a radical and something that's not a radical? Nope. So this is my answer for tangent. Okay, I would encourage you to pause the video right now and see if you can do question B. I will do question B in a moment. Pause the video, see if you can do it on your own. All right. So for question B. So now this is the opposite over the hypotenuse. So opposite of theta is 12 over the hypotenuse 13. Does not reduce. Cosine ca a over h. Adjacent to theta is 5. Hypotenuse is 13. And then tangent TOA OA, opposite is 12, adjacent is 5. 12/5. Oops, sorry, 12/5. All right, last section. Use the given trig function to find the other two. Hint, drawing a picture will help. So I am given the sine of theta. So let's draw a right triangle. It will not be drawn to scale. Ooh, that right triangle kind of wasn't right. There we go. Will not be drawn to scale. I'm going to put a right angle in there. And then I'm going to put theta in one of these angles. It does not really matter which one it is. Just pick one. I'll pick this one right here. We are given the sine is 4/7. The sine is opposite over hypotenuse. So opposite of theta has to be 4. And the hypotenuse of this triangle has to be 7. I have to find cosine and tangent. In order to find cosine, I need A over H, and I do not know A. So to find A, let's use the Pythagorean theorem. A squared plus B squared equals C squared. Let's see, 7 is the hypotenuse, so that's the C squared. So I'll do 4 squared plus B squared equals 7 squared. 16 plus B squared equals 49. Then I'm going to subtract 16 from both sides. Get 33. Then I have to square root, and remember when we square root, we have to plus minus. But then we can just reject the negative because this is a triangle. Square root 33. When we think of factors of 33, 3 and 11, neither of those are perfect squares, so this is the simplified version of square root 33. So my adjacent side is square root 33. So I go back to finding the cosine, and I put square root 33 over the hypotenuse 7, and that is my cosine. Tangent is TOA. My opposite is 4. My adjacent is square root 33. Of course, I cannot leave a square root in the denominator. So we're going to multiply the top and the bottom by square root 33. Multiply straight across and I get square root 33. On the bottom, we get square root 33 squared. On top, 4 square root 33. On the bottom, the squared and the square root cancel each other out, so I just get the 33. Can I cancel the square root 33 with the 33? No. The square root 33 is under a radical, 33 is not, therefore they cannot cancel. That's our answer. I would suggest that you pause the video and you try question B. Then when you unpause it, I'll have the answer for you. All right, the last cosine theta equals 5 over 6. I'm going to draw a right triangle, and I'm going to pick one side to be theta, or one angle to be theta. It doesn't matter which one. Cross from 90 degrees is the hypotenuse. Cross from theta is opposite, and adjacent is next to theta. Here we've got cosine, and cosine is ka, A over H. So my A is 5, is 6. To find sine, I need to know opposite. So I'm going to have to do the Pythagorean theorem. A squared plus B squared equals C squared. And the hypotenuse is 6, which is C, so 6 squared. We've got 5 squared. Getting ahead of myself there. 5 squared plus b squared for a and b. So we've got 25 plus b squared equals 36. Subtract the 25, get b squared equals 11. So we're going to square root both sides, and when I square root, I got to do a plus minus. But when I do that plus minus, I'm going to reject the negative because it's a triangle. So my b value is square root 11. So that's going to be opposite. To find the sine, so katoa, we do opposite over hypotenuse. So square root 11 over 6. That cannot reduce. And for tangent, we do toa, O over A. We put in our opposite, square root 11, over our adjacent, 5. And that does not reduce. And that's it. So you're going to work on the worksheet that is uploaded to Canvas, and then you will be submitting that worksheet to me. You are more than welcome to work on that worksheet on Kami, since you will be submitting this electronically to me. Please go on Canvas to learn how to submit it electronically. As of this moment, while I am recording the video, I haven't figured out if I'm going to have you submit it on Canvas or on Google. I haven't learned how to do what I prefer to do yet. So I will change the directions on Canvas as soon as I figure that out. Have a wonderful day and have an amazing spring break, and we will talk soon. Oh, also remember, you can contact me if you need any help. Give me questions, email me, or you can find me on Instagram, or you can find me on Twitter. I'm also on Facebook, but I know a lot of you don't use it. Look for Vicki Criswell.